So in this section, we're going to talk about the antiderivative. This is also known as the integral or the process of integration. When we take a derivative of a function f of x, that's so we can find out how a function is changing exactly at the value of x. That's that instantaneous rate of change that we've spoken about. You know, the derivative is the slope of a tangent line to f of x at x. So it's that one unique tangent line to f of x at x. And the slope of that line tells us how the function is changing at x. However, if the derivative has already been taken and we want to undo it to find what the original function was, we must reverse the process of the derivative. So this is what we call integration. So we're going to reverse the power rule first because that's the one we learn first. So remember, when you take a derivative, the derivative with respect to x of a base x to a power p is the power times the base to the power minus 1. Now, we're not worried about the chain rule now, so we're looking at a base of x that has a derivative of 1, so we don't have to continue to chain on that derivative of the base. So we multiply by the power, and we subtract 1 from the power. That's the derivative power rule. When we do the integral, we have to reverse this. So the integral, and this is the symbol, it's a stretched out S. That's what it really is. And later on, we'll talk about why we use that symbol and why S, this stretched out S, is the symbol we use. Now, notice that we have this dx. This tells us the derivative has already been taken of x to the p. And this tells us we want to reverse that derivative. So we take the base, and instead of subtracting 1 to the power, we add 1. Instead of multiplying by the power, we divide by the new power. So we're reversing this. Look, instead of subtracting 1 from the power, we're adding 1 to the power. Instead of multiplying by the original power, we have to divide by the new power. So here's our first couple of rules. Take the integral of a constant. Now notice there's no x variable here. That C stands for a number. Where the derivative has already been taken, then that answer is just going to be c times x, the constant or coefficient times x. Why is that true? Well, same power rule. C times x to the 0, because look, x is 0 is 1. So when there's no x, it's really a base x of 0. We add 1 to that power 0, we get a 1. We divide by the new power 0 plus 1. And look, we get c to the 1 over 1. So it's just cx. So let's take the derivative with respect to x of 7x. And we know that's a 7 because the power is a 1. And we do 1 times 7 is 7. You subtract 1 from that power, it becomes a 0. So x to the 0 is 1. So we just have 7. So if we go opposite, integral of 7, where a derivative has been taken, we have to add 1 to the power. Instead of 0, it's a 1. And we divide by 1. So that's a 7x. So the integral of any constant is going to be the constant times the variable with which the derivative was taken. So if it's the integral of 10 dy, then it's going to be 10y. This tells you the derivative was taken with respect to y. Now, a couple of things. As I mentioned, the integral symbol is this sort of stretched out S-looking symbol. It must always be paired with dx. So whenever you're taking an integral of any function, there has to be this thing called the differential. This is saying that the derivative was taken. So, and now another note. Since the derivative of a constant is always 0, we always write plus c when taking what's called an indefinite integral. Now later we'll do this thing called a definite integral where we are given the values of x. So the values of x are known. But when we're doing an indefinite integral, we don't know the values of our variable and we'll have to write plus c every time. So let's do example 1. I've got to find the integral of the polynomial 3x squared minus 7x plus 4 dx. Again, you're going to have the dx every time you have the integral symbol. So I'm going to rewrite each term. So the integral of 3x squared dx minus the integral of 7x dx plus the integral of 4 dx. And notice each time I wrote the integral, I wrote that differential, that dx, to say the derivative has been taken, and we're going in the reverse order. So the integral of 3x squared is going to be 3x to the 2 plus 1 divided by 2 plus 1. Now, at some point, you're not going to write 2 plus 1. You're going to go ahead and write that as a 3, and that's fine. We will do it this way, at least for now, until we get used to it. So this is going to be 7x to the 1 plus 1 divided by 1 plus 1 plus 4. Now look, that's x to the 0, so it's going to be x. Remember, the derivative of 4x is 4, so the integral of 4 dx has to be 4x. Now last thing, I'm going to write a plus c here because any constant could have been present whose derivative had been taken. And so we'll always do this, always, whenever you're doing an indefinite integral. Now let me show you how you'll be able to tell the difference. When you're doing a definite integral, you'll have something like this. You'll have numbers here that tell you that x starts at 0 and x goes to 5. That's a definite integral. So without those endpoints of our interval, it's called an indefinite integral, and we must write plus c. Now I'm going to simplify. 3x to the 3rd over 3 minus 7x to the 2 over 2 plus 4x plus c. And that's going to give me an x to the 3rd minus 7 over 2x squared. And you can write that 7x squared over 2 plus 4x plus c. Now, if I want to check this, I take the derivative. So I'm going to take the derivative with respect to x of x cubed minus 7 over 2x squared plus 4x plus some unknown constant. Well, the derivative of x cubed is 3x squared. The derivative of the second one is 7 over 2 times 2 to the times x to the 2 minus 1. It's going to be 4, and the derivative of that constant is going to be 0. Cleaning this up, 3x squared, and so these 2's will divide, so I'll get a minus 7x plus 4. And so that's my original function whose derivative had been taken. Now let's compare that. 3x squared minus 7x plus 4 was the original. And again, this is just the check. It's not required. You don't have to check it, but it's an easy thing to do to make sure that you've gotten your integral right.